So, there we are. A few seconds late. But better late than never, I guess. I'm just going to tune down that background music a bit. And yeah, welcome. It's that time of the week again where I get to code a bit on my pet project in Elm, my Twitch chat, and like ultimate overlay basically, where I want to show all the things. Yeah, so as I was showing in my countdown slide, I have two things I want to work on today. Adding an interactive roadmap, so just a feature or like a portion, a window I can slide in that shows the steps I want to take today or accomplish today. And interactive means I want to be able to like check things off. And this leads up to the second part, basically, where I also want to be able to persist the stage of this overlay into local storage, so that if I reload the browser window that is displaying the overlay, like all the things that I have checked already will stay checked, and so on and so forth. So without further ado, actually I should probably open the page on my development computer here as well. Index. So that's how that looks currently. Yeah, so maybe start actually by adjusting the init function here again. I also managed to get my language server working again so that I can do all the nice things like jump to definitions and getting inline feedback. So that's really great. Makes it a lot more fun to develop this stuff again. And yeah, so screen will be the weird Windows term that I chose for the not countdown state of the model. So if I refresh now, did it compile? Oh no, I have to start my watcher again. Where is it? FS watch. I have to make a little change. Save. Compiling again, reloading, and here we see like, okay, here we see also, I mean, I'm doing already persistence to local storage. We can have a look at this code in a second, but as far as I remember, I'm just writing the messages that I'm getting from the Twitch API directly into local storage. So there is only accidental lineup between what is in local storage, and like my Elm application is not actually writing that to the local storage itself. So if I want to add anything regarding the state of the checkboxes of my agenda that I'm going to add, then I probably should put the Elm application into charge into serializing stuff into local storage, so that when we are deserializing it again, like it always matches up. All right, so let's start by adding a new view or modifying the view to actually show this agenda. So where's our view function? View here, we have here the section for the countdown, and maybe we actually just separate this out into, extract this into a proper function, into its own function, so that our view function is a bit more concise again. Change countdown view. Just going to pass on the seconds total here and dump this into a new function. Countdown view. Seconds total. I'm just going to stick with the same identifier so that I don't have to adjust the implementation. Missing type annotation. That's fine. It should still work. Did it compile? It compiled. I can also now use the language server again to infer the annotation. So that this is happy again. And now we can go to our top level view function again, and maybe, I don't know, div. Here we only have the div for our messages, and so the ultimate vision I have is that I have the messages here on the right, and then maybe the agenda on the left here. So we will add another level of indentation here and just add a wrapper for the messages and the new div for the agenda that I'm about to add. So here, oops, comma, and maybe I just create a new function right away that I call agenda. Agenda is a div, and it contains, let's call them agenda points or roadmap. Wow, like I'm too far down, too lazy to rename for now. Okay, so, or maybe we just map. Well, we just, yeah, let's just create it on the lit block here. Agenda points, a map, and we are mapping an li list item without any attributes over point content, and let's say point content are for now just strings. So we'll have for today's agenda, like as let's say add view with ToDos, make ToDo off tickable, and persist ToDo states to local storage. Boom. This will not work because our LE here expects a list. So maybe we just do an anonymous function here, lambda function. That gets just a string and creates an li with this string, with a text node with a string. Does this compile? It compiles. Reload this. Oh yeah, nice. So it did definitely render something. So now let's check what's the markup of this. It's a big mess here. I think I will just try to adapt some of the CSS that I have for the messages. Let's give this outer container a name as well. No, that's not the one. This one, let's call it Windows. And we want that one to use up the whole screen. So we say width is 100 view width. So it takes up 100% of the viewport width, and we do the same thing for the height. And messages, transition, position absolute. Yeah, that all looks good. So we do something similar for our new agenda div, agenda, position, absolute, top 0, left 0, and width maybe 25% of the viewport, and height we say 100%. We could work with percentages here just as well. I'm just going with these units because they're absolute and it's just easier to reason about no matter where we move this. Why does it not work? Did I give our container, our agenda container, the right class? I did not. So let's add a class attribute here. Agenda. Boom. Reload. There we go. I think we're going to give it the same background color, this very boring gray here. And I also feel at some point I want to switch to SCSS or SAS, probably more precisely. Background color 333, so that I can use nice nesting and CSS variables, although I think nowadays you can even use CSS variables. Oh, maybe I should look into this. I keep that on the back of my head, even without SAS. So that looks huge. It's a bit big maybe, so font family. Yeah, I will probably just steal this as well. Probably could change this from the body directly, so I just actually drop this in here. Font size 42 is a bit too big. Maybe I do. What happens if I just remove it from the body? Yeah, that looks a lot more reasonable. Drop in some padding here. 1 EM. That looks nice. I don't know, maybe we just use some Unicode things to Unicode to have a nice checkbox. Checkbox unchecked, whatever. Ballot box. What is ballot box? Okay, yeah, cool, that works. Can I grab this one somewhere here? Browser test page. Image. Here, nice. I'm just going to grab this one and we're going to put this in our li here. Text, boom. So now we should have, oh, that does not work. Ah, yeah, I think I didn't actually set the encoding here, so I know I can do this with a meta tag, meta HTML encoding, UTF-8 sounds wonderful. I'm not a huge fan of W3 schools. Oh, this is actually German page, interesting. Yeah, my browser local is still set to German, so sometimes I just get German content. Nice. So now the browser knows that the page is encoded in Unicode. It is able to give us a nice Unicode character here. And maybe can we cheat a bit and just add some space here? No, not really. Well, we can adjust this later on. So now we have our unchecked. And do we have something? I mean, if there's people have been searching for unchecked, so checked, checkbox, Unicode. Yeah, there's something going on here. I don't know. Ballot with, okay. Oh, this is really an image. Ah, this is how it looks. Let's just drop it in to see how both states would look. Yeah, that's not too bad. That's not too bad. So we can use this. Okay. So how do we represent this in our application now so that it's, I guess we want to extend our model. So we have our messages. So yeah, maybe we just drop in a list of to-dos here. To-dos, list to-do. And we introduce a new type, alias probably to do, and it's this kind of record thingy where we have a label that's a string, and we have a done boolean. Bool. Does it compile? No, it does not, because now our init function does not initialize this new field. So let's go to our init function. Init, go to definition right here, and just throw it in the middle here. To-dos equals, maybe we put in right away. One in right away. It's what did I call it? Label equals extend model done balls. Is the compiler happy again? It is. So now instead of rendering our fixed list of to-dos here, we want to map over to-dos that we get from our model. So let's say here, map over to-dos. So now this has a label and a done field. I'm actually not sure. Oh yeah, it seems to be valid syntax, so that makes me happy. And now we have the agenda call here, which should get the to-dos from the model that we deconstruct here. To-dos. Is compiler happy? No, because we don't have an S here in line 168. So this is label. We reload this, extend model, that's wonderful. And now we just have to switch between the two Unicode charts here depending if we're done or not. So maybe really quick and dirty, throwing in a conditional here. If done, then it's of course it's exactly the wrong order. Else this one. If done, then this tiny thing with the, I'm not sure you can see that, the Unicode with the check mark. So compiled, refresh. So now it's not done. Or maybe actually increase the font size here a bit. Font size 1.2 EM. It's equals 120% basically. So that's nice. And if we go to our init function again and switch this task to be done, where is it here? Done equals true. Then this should be checked. So yay, that's nice. So maybe we wrap this in a span. So let's do a little let block here. Or maybe we just have a top level function. Let's say checkbox checked, and we just rip out this whole expression here and replace it with checkbox done, and make this a bit more sophisticated. So we want to definitely have a span wrapping this. Let's call it class, give it a class checkbox, and then we say, oh, I mean, that's still basically the gist of it, so it's not that much more sophisticated or complicated, which is good. We can remove a bit of parenthesis here by using this, I think it's a piping operator, the official name. Checkbox, no, it's not done. If done is the right condition here to check. No, if checked, sorry, my bad. Checked, boom. Does it compile? It compile. Should still look the same, but now if we inspect this one, we should see a wrapping span here that we can target to make it a bit bigger and give it some padding. So let's say agenda. Just copy this selector and add the checkbox here. Checkbox. Closing bracket, and say font size 1.2 EM, and margin right 1 EM might be a bit too much. Let's see, let's refresh. Yeah, maybe 0.5 is enough. 0.5, make it yet a bit bigger. Boom. So that's a bit more, or maybe actually even 2 EM. Nice big checkbox. Okay. And we'll give it also cursor pointer, so that when I hover it with my mouse, I get the nice little hand here. Boink, boink, boink. All right, that's pretty neat. Maybe we remove the weird dots in the front from the UL default styling. So that's part of the agenda, I guess. Agenda points. Oh yeah, okay, the agenda should actually be a UL because it contains LI. So list style type is the CSS attribute to change the styling of the list items. So now, okay, interesting. I think we have inherited a default margin for our UL. Margin none or 0. I think that should be a 0, I guess. All right, that looks good again. Okay, so next on, when I click on this, so extend model, yeah, actually we can maybe put some motivational points in here. Init ToDos. Init ToDos. So that's the one. Extend the model. That works. And now we are going to add a second one. That is make to do checkable done false. So this is now correctly representing the state of today's episode. Yeah, so let's... Okay, we can add the third one as well as already. Persist state of to-dos across page reloads. Boom. That did not work. Oh, I did. I just reloaded too quickly. Yeah, that's also not super pretty, but well, I'm not going to worry about this too much for now. Okay, make to-do checkable. That's the thing. So there are different ways to approach this. I think I will approach it bottom up. So when I'm rendering the checkbox, I'm going to introduce like an on-click handler basically, and that will require me to introduce a new message. So let's see how that works out. Where is our checkbox? It's here. So now we say on click type mismatcher. Yeah, now it says like, okay, what I need something to construct a message. So actually I don't want this checkbox to know what to know about to-dos, so I'm just passing on a message. So I'm going to just introduce a new parameter here, and then here in our agenda, where we actually know about to-dos, I have now to create a message that identifies, or that I can pass on which checkbox I clicked as well. So I think I'm going to just use the index of that to-do in the list of to-dos to identify it. So I will upgrade this map to an indexed map from the list module. Exactly, that's perfect. I don't know why I messed up my indentation, but I also don't care a lot. And now we actually get two parameters, I believe, our object and an index I. So I will create, and now I will create a new message, come up with a name for it. Check to do or toggle to do. Toggle is better so that we can also uncheck it again. Toggle to do I. So this will now tell me, okay, you don't have a toggle to do variant. So now I'm curious again. I'm still experimenting or exploring what the Elm language server can do for me. So I'm going to bring up the actions here, but what I would love to see here is that it offers me to introduce the new variant to our message type, but apparently that's not that smart yet. So I will just copy this identifier here and jump to type our declaration of our message type and just add this new variant here. Boom, toggle to do. It takes an int that is the position of the to do in the list of to dos. So that's great. So now, now I'm recording a new macro. That's not what I wanted. I wanted to write it. And the compiler is still unhappy because this argument is an anonymous function of blah, 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 blah. But index map needs, yeah, I guess I messed up the, maybe I have to add some parenthesis for it to be able to be parsed. So let's jump to that line. Which line was it? 1676, 176. Maybe it's happy when I wrap this in parentheses. Indexed map, closing bracket, why not? Maybe it's upset about this construction here. If I just change this to do, I think I just internalized the proper notation for multi-argument anonymous function. I was expecting a closing parentheses. So why doesn't it work without? Okay, now of course I have to say todo.done, todo.label, and now it's whining again about the... Oh, it was right all along the format. It's just that the index is the first parameter and not the second one. So it's probably just going to be like this. And there we go. Yes. Now it's complaining about the call of agendas. Diff call 142. Agenda to do's. Why are you unhappy? This diff call produces it's agenda to do's. Agenda points. Let's generate some signatures. So this is wrong. Agenda should not receive an integer. So let's fix this, and then maybe the compiler will give us a better hint. Yeah, it's about this indexed map. Ooh. What's the signature of indexed map? Indexed map. List index map gives us a list of B's, so that should be okay. What's going on here? Am I missing something? I mean, I'm obviously missing something, so I don't know. To do. Let's do the little expansion here. After all, to do done checkbox takes to check a bool and a message. That looks good. To do label. But this UL produces, yeah, I know that it produces this, but why does it produce that? So if I just do, I'm not sure if this is actually the right point here to fix. So now it's complaining about us not handling the to-do variant in our update function. That's what I actually expected and I want to look into. I just don't know why this index map. So let's write a new, let's make this anonymous function not so anonymous. So let's call it make point. It takes the index and the to-do, and it returns this li. So this expression here, and we're going to write a signature for this one as well now, just to make sure our understanding, or like see where our understanding, my understanding is not aligned with the actual types here. So it should take an int and a to-do, and it should return an HTML message. And then we can revive this line and just say indexed map make point over to-dos. And now hopefully the compiler, I renamed it to, what did I call it? Index and now something is off with the body of make point. Okay, fair enough. It's the way I construct the checkbox that there's something wrong. I bet if I just delete this checkbox call, everyone is happy, happy, happy. This value is not a function, but it was given 3 arguments. Interesting. What? Oh, because there's this lingering thingy here. Let's delete this one again, and now it probably complains about the update function. No, it does not. This ToDos is... But index maps needs the second argument to be list to do. Am I stupid? What's happening here? Int A B, list of A's. Okay, I would just want to keep it commented out. I'm just going to put in the foo here. To do, okay, this type signature that was derived here is a bit weird, so let's be explicit here. Say this is a list of to do. Okay, cool. Now it's failing where I expect it to fail. Let's bring back the troublemaker. LE produces. Why does this produce still something? Checkbox. To do done. If I remove this, it compiles, yeah, at least to the point where I expect it to. Checkbox. Okay. On click, is that the... Oh, let's derive the... Infer is the correct verb here. Takes a bool and a message. Let's make it overly specific, although we don't need to. Takes a bool and a message and returns. Okay, and now I think we are getting to the second argument is not what I expect. No. What? Toggle to do 0. What the actual? Go to definition. Oh, it's because I declared 2 ints. Oh, that's really nasty. I don't remember doing that. So okay, but now I know actually what happened. So it's because I only gave it 1. It still was expecting another int, and that's why all these things had this dangling int in the signature. So let's save this, and now we should see again the missing possibility thing that I actually wanted to address. Okay, so now we can finally go and look at that one. So let's go to our update function, go to definition. Here it's marking all this stuff because it's missing this new variant. So let's say toggle to do index, and for now let's just do nothing to have it see it compile again. So it's compiling it again, and I can refresh the page and it loads again and it looks how it was looking. And now let's create a helper method, a helper function here. Let's say, or toggle to do takes a model, returns a model, and takes the to-do index, of course, as well. And let's write up our intention in a signature form. So method name, and it takes a integer and a model and returns a model. Toggle to do index model equals. Okay, let's I know already there's some in-between steps, so I'm already writing a let block to allow us to declare some local expressions. And ultimately what I want to return is model and to-dos equals updated to-dos. And now, sorry, we can kind of work our way back from that expression. Whoops. So what is updated to-dos going to be? Updated to-dos is going to be a version of the old to-dos, of the original to-dos, but where we updated the to-do that we indicated by flipping the done state. So since we're going to operate on the to-dos by index, probably indexed map is a good candidate here again. And we're going to have a function update. Let's just call we are updating a to-do. So let's call it update to-do. And we are going to map over the to-dos. Now we just have to write update to-do. So, whoops, update. The job of update to-do, I would argue, is that if it operates on a to-do that's not the one that's identified by to-do index, then it just keeps it. And if it's the one, then it will flip the done flag on this one. So we know now I is the index for the indexed map function is passed in first, and then we have a to-do, and we can say if I equals to-do index. That's the complicated case that I will just skip so I can deal with the easy one first. If I is not equal, doesn't equal to-do IDX, then I just return to-do. And otherwise, I'm going to return an updated version of the to-do. And I'm using this squiggly bracket syntax here where I can just say what's the object that I'm going to update. It's this to-do record object, and then I can have a comma separated list of fields that I can update here. Yeah, and I want to update the done field of our to-do record. So I'm going to say done equals not to-do done to invert it. And I think that just might be it. So let's go over the logic again. We're getting a model and we're updating this model. We're updating the to-do fields with the updated to-dos. And the updated to-dos is a processed version of the original to-dos, where for each original to-do we call update to-do. And by the indexed map, we also get the index, the position of that to-do in the list of to-dos. And if we are at that to-do that we define or refer to by this index, then we're updating the done field of this to-do by inverting it with the not operator. Otherwise, we just return the original to-do. So let's save this. Let's see if it compiles. It compiles. Let's refresh. And now we can check and uncheck to-dos. That's really nice. That's really nice. That makes me happy. So now basically we can check those 2 points. I can also try to check the third point, but if I reload the page, then we see, okay, it's not actually, shouldn't actually be checked. So now comes the actually a bit more involved part, I fear, of writing these to-dos together with the old messages that I also want to persist. Basically the whole application model I want to persist and write this into, although I don't know if that's true. I don't know. But I definitely do want to persist the state of the to-dos and the state of our chat messages here into local storage of the browser. So how do we go about this? Let's revisit how we currently store the messages in local storage. So I guess there's some hard-coded JavaScript here in my index.html. And yes, old messages item. That gets loaded when the page is loaded. So I'm just loading the old messages. These are stored as a string, like local storage only stores strings. So I have to parse them from this JSON string. And then I'm passing those on as old messages. And now, like, I have to put in something here that also gives me the state of the to-dos. But instead of manually tracking this here on my HTML level or my index HTML level manually, I just want to read this key. So maybe I want to do something like model state, let's call it this, and model state, and then I just want to pass in model state here. If model state is empty, I probably want to do something similar to this. So let's say model state storage item or string, and then we change this here to model storage as well. Model state again, and it's model storage string, and this time it's not, the default is not going to be an empty array, but rather an empty object, because I have the feeling we want to have one field for the messages and one field for the to-dos. So this will be passed into our flags, handed over to our application at init time. And so let's see how this is handled on the other side. Let's go to the definition of the init function, because that's the one, it's directly below. That receives a list of strings, tuples of two strings. So that's definitely not true anymore. And we probably don't want to rely on a primitive thing like this, but maybe we introduce a new type for the storage state. I will call it alias storage state. So this will be the information that I want to write to local storage. So I want to have messages, and these should be a list of messages, I guess. I don't know, how is message defined? A message has an author and a message, so that looks nice. And we'll have a list of to-dos. So the reason why I don't want to store the whole application state, the model itself, where is it defined, is because it has weird things, like if the messages are faded in or out, or the time zone. Those are things that I don't want to write to local storage. Those are things that are determined at runtime and that the application can figure it out itself. I just want to store the things I absolutely have to store in local storage. So these things would, to my current knowledge, be a list of messages and a list of to-dos. And one limitation of Elm ports or flags, Elm lang, let's look at the documentation, is that we cannot, where are the flags? That we cannot use custom types. There's a dedicated list of types, verifying types. There are a bunch of types that can be given as flags. So these are either these primitives, then arrays, tuples, or actually we can even give records. I didn't know that. Like, or I can just give a JSON decode value, and well, I now I really want to try a record, because like the other way, that's what I thought would actually take more time, would be for us to decode these JSON values, because JSON decoding in Elm is always parsing and validating or verifying combined. So it's a bit more work than of a lift than in Java or Ruby, where you usually just say like, oh, parse it, and then I have an object which may have keys or may not have keys. And like, yeah, so if I don't have to do this right now because I can let Elm take care of that, then that makes me very happy, of course. So let's say storage, but I think we are going to directly see why I might want to use the other approach after all. Okay, now it's of course complaining that these messages are not messages, so I can actually, but I can still deconstruct this into messages and to-dos. So now I can assign these messages here, and instead of init to-dos, I can now just use the to-dos that I get passed in through my flags from my local storage. Messages. This should be, is it happy? Is it happy? It's not happy. Because now actually I don't have to do the whole mapping stuff neither, because it's not a list of tuples, it's directly messages as declared by our storage type here. And it compiles. So this sounds like I'm used to, and it compiles, it works, blah, 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 the good old strictly purely functional promise. So let's reload the page and see what the console has to say. Bam! Problem with the flags given to your Elm program on initialization. I gave it an empty object, and it's rightfully complaining that this is not a valid record version or JSON version of our storage state. So actually, I think I can cheat my way down a bit further by just saying messages are an empty array and to-dos are an empty array. Is this valid JSON that I produced there? Let's reload. No, it's not. I think I have to... Or I can just say, I know, I can just actually create a JSON object and then just JSON stringify it. This way I don't have to deal with being able to create valid JSON manually. Stringify, there we go. Reload. Bam, it works again. Obviously, now that we are passing in this empty object, everything's empty, which is to be expected. So how about adding some new to-dos? So maybe so the reason is, the question is, how do I pre-fill my local storage now? And I think for the to-dos there is a nice little hack. I can just say if there are no to-dos, basically I want to pre-fill my to-dos from this static list of init to-dos. They obviously should all be false. So I can say if there's probably a nice empty message from the list module is empty messages, then, oh no, actually that's the wrong part here. I don't want to mess with the messages. I want to update the to-dos. If is empty to-dos, then init to-dos, else to-dos. So this should at least bring back our to-dos. There we go. We can check them, but if we reload them, then we get back to our init ToDos state. So what we want to do now is that once I click on one of those to-dos, I want to write the storage state into my local storage so that when I reload the page the next time, I'm going to use the state that was serialized into our local storage. That means we have to look at ports again. So just to bring back the idea of ports, ports are the way to interact with the native JavaScript interface of the browser in a way that it doesn't break our very strict application information cycle, if you will, because we cannot wait for JavaScript to perform its job eventually. So the way that ports are working is basically it's a purely message passing approach. So either we can receive a message from the JavaScript world through a scriptscription, which will trigger a message that we have to handle in our update function. So we are covered on that side. And the other way around is if we want to process something on the JavaScript side that was triggered by our Elm application, it's kind of a fire and forget mechanism the other way around, where we just execute or enqueue, or I don't know what's the proper term for it, but like when we process one of our messages in our update function, we can issue is probably the right verb to use. We can issue a command that will use one of those ports to fire a message to our JavaScript world. So basically what I want to say is when I toggle a to-do, not only do I want to update our model to reflect this change in state on our to-do in our model and eventually update the view, I also want to fire one message across this port that I will create in a second to the JavaScript to update the state or rewrite the state to our local storage. So let's create this port. We already declared our main module to have it contain ports, so we don't need to do this again. But we do want to create a new outgoing port. So let's call this one update storage. And the storage, it will, what do I want to do? What do I want to do? Let's look at the documentation, ports in JavaScript, blah, 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 ports in Elm, send message. Yeah, okay, basically, yeah, exactly. I need a function that creates a command in the end because that's what I want to return from our update function. And do I send a string? I guess I can directly, if I can receive a record through my flags, then probably sending is recommended. Like with flags, certain core types can pass through ports. Okay. This is from the time before JSON, la 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 la. Okay, I think I'm going to try to go the lazy route here and say storage state and command message. So now I have a function that I can pass in the storage state and it will create a command message for me. So let's grab this identifier and go back to our update function and put this here. So, but I do need to pass it a storage state. So let's create a new function and call it make storage state from model. And no, that's not what I wanted. Still not. Let's create the signature to explain what the intention is here. We want to receive a model and we want to produce a storage state with the information that's stored in the model. It's actually not too hard. So we can again deconstruct here messages and to-dos from our model, and we are going to create a new storage state, which incidentally also has messages. So it's just a matter of assigning those keys. To-dos. So is the compiler happy with that? It is. So that means our Elm program is working correctly, but we don't have anything yet on the HTML side or the JavaScript side, I should probably say, that consumes the messages sent from this port. Client on, that's the TMI client. I think let's consult the Elm guide again, how to incoming message, outgoing messages, how to consume or subscribe to these messages that we're sending from the Elm world into the JavaScript world. And this is the block that I was looking for. So I'm just going to grab this and paste this here. So we have our app, which is the entry point for our Elm application. That's great. And we're accessing the ports field where all the ports are exported or exposed, I should say. And we want to subscribe to the port that we just declared. It's not called send message, it's called update storage. So let's grab this and subscribe, and we're getting a message, and we are just going to console log this message because we have been working way too long without actually trying out what I've added. So this doesn't recompile because I just changed the HTML. Let's reload this. I'm going to bring up the console here and clicking, boom, wonderful. So we see we have our start state that got serialized into a JSON object. It has the 3 to-dos with the texts and the done fields, but something is a bit off. I checked the first item and the done state is still false. And the reason for that is that when I created the when I'm calling the new make storage function, I'm actually calling it with the model before I toggled the to-do. So I should probably introduce a little local expression that I'm calling with toggled to-do. And I'm assigning this expression to that. I'm fixing my indentation, and then I'm putting that in here. And now I'm going to serialize the model with the toggle to do as well. I'm going to reload, click here, to dos, and now the first to do is actually toggled. So that's great. But if I reload, then because we didn't write it to local storage yet, then it's still not reflecting the states. So the only thing we have to do now is probably calling set item on local storage. I don't know these APIs from the top of my head, but usually you can make a good guess if you see one of the calls, set item, and I guess the first one will be the key and the second one, whoops, will be the value, and the message, as we saw, is an actual JavaScript object. So to be able to store it in local storage, we have to stringify it. So I'm going to do this right away. Stringify. I'm going to throw in this message here that we receive from our port. Remove the debug statement. Save everything. Reload. I'm going to check the first message, and now comes the moment of truth. I'm going to reload the page, and it's persisting. So if I toggle these items, reload, it saves the state across a page reloads. So that's awesome. And yeah, that took me about an hour, which is roughly what I'm aiming to keep each episode. So to my one viewer, thanks for staying with me. I'm going to share the recording on YouTube, and See you next time next week. Bye bye.